Okay, hi everyone, welcome back to this video series on Introduction to Firewalls. Order matters. The order in which the rules are processed matters with IP tables commands. Because of this, IP tables has the convenient -a command that appends commands to the end of the processing chain, and the equally convenient -i command that adds commands to the beginning of the processing chain or a user specified location. Of course, an even better strategy is to plan for the order of processing of commands before you define your rules. Unlike some other firewalls, IP tables applies each filter command and stops processing commands once a match takes place. For example, if you create a rule that allows all network traffic and then you create other rules that deny specific types of traffic, you should make sure that the drop all rule is at the end of the chain. That way, Linux stops processing the rules as soon as it recognizes that the packet should be allowed. The drop all rule won't be processed. If you reverse the order and applied the drop all rule first, Linux would examine the packet and drop it when drop all rule is encountered. The rule that allows the packet would never be processed. It's a good practice in designing firewalls to place the rules that allow network traffic first and then apply rules that deny traffic later. To create more involved rules, you can create additional user-defined chains, which are chains that perform further processing, or add conditional statements, or create rules that contain more than one condition that the packet must match in order for a rule to apply. Finally, rule processing doesn't end when a packet is logged. You can make a decision to allow or drop a packet even after a rule has been applied to log the packet. IP tables, options, and conditions. Options are the last component of IP table commands that you need to have under your belt in order to build firewall rules. Options determine how a command is processed. Most often these options are conditions that are checked before a command is applied. These conditional expressions are evaluated by Linux to decide whether a command should be applied or ignored for a given packet. Table 1413 lists the most commonly used options, including conditional expressions. So -i protocol specifies to what protocol the rule applies. The parameter protocol can be TCP, UDP, or ICMP. You can also use the name of the protocol if it is listed in etc/protocols, or the protocol number. You can apply the rule to all protocols by using the number 0 or the word all. Finally, you can combine several protocols in a command by separating them with commas. For example, -p47 refers to all packets that use protocol 47. The generic routing protocol GRE -p TCP.UDP matches all packets that use the TCP or the UDP protocol. -s source address mask specifies the source address of a packet. The optional mask parameter specifies a subnet mask expressed in classless IP addressing. This addressing scheme uses a single number, one that specifies the number of bits in a subnet mask. For the subnet mask, for example, -s 192.168.1.1 indicates a packet from the IP address 192.168.1.1. -s 192.168.1.0/24 indicates a packet from any address between 192.168.1.0 and 192.168.1.255. The number 24 indicates that the range of the addresses includes all IP addresses where the first 24 bits corresponding to the first 3 octets are the same. -D destination address mask specifies the destination address of a packet as in the source address. You can specify a subnet mask to refer to an address range -S 23.2.4.7, for example, indicates a packet addressed to the IP address 23.2.4.7 -S 23.0.0.0 /8 indicates a packet to any address between 23.0.0.0 and 23.255.255.255. So source port specifies the source port of a TCP or UDP packet. Because only these protocols use ports, this condition can only be used in conjunction with -P UDP or -P TCP options. You can refer to a range of ports by using a colon between 2 port numbers, for example, -P UDP -source -port 53 refers to all UDP packets with a source port of 53. -P TCP source port 0:1023 refers to all TCP packets with a source port lower than 121 or 1024. Finally, if a service is listed in the etc. services file, you can refer to the name of the service instead of a port number. Destination port. This option is analogous to the source port option, but it refers to the destination port of a TCP or UDP packet. For example, -P TCP destination port 80 refers to all TCP packets with a source port of 80. UDP source port 1024.1100 refers to all UDP packets with a source port between 1024 and 1100. The -I interface specifies the network interface on which an incoming packet is received. For example, you can refer to all packets that arrived on the interface ETH0 by specifying -I ETH0. If you want to refer to all interfaces for a specific type, you can use a plus sign as a wildcard character. For example, -I ETH plus matches all packets that arrive on an interface with a name that begins with ETH, such as ETH0 and ETH1. -0 interface. This option is analogous to -I option, but it refers to the output interface on which a packet is to be sent. For example, you can refer to all packets that are about to be sent on the interface ETH1 by specifying -0 ETH1. You can also use the plus sign as a wildcard character with this option, SYN. This option specifies TCP packets that establish a new connection. The first packet of a three-way handshake operation when a new TCP connection is established carries an SYN flag, but not an ACK or FIN flag. The SIN option tests packets that look like they might be trying to start a new TCP connection. They have a telltale SYN flag, but no ECK or FIN flag signature. Packets that follow later during the three-way handshake or during a data connection don't meet these conditions. They also don't meet the criteria of the SYN option. Because of this behavior, you can use the SYN option to check whether a packet is the first packet that is part of a new connection. For example, -p TCP minus SYN tests whether a packet is part of a new TCP connection. This test is most often used in rules that disallow the establishment of a new TCP connections. ICMP type. This option tests for specific ICMP types and can only be used if the ICMP protocol is specified. ICMP packets have an option field that specifies the purpose of the packet. You can use either the name of an ICMP type or the corresponding number to filter specific ICP and packets. For example, -p ICMP minus ICMP minus type source quench applies to all source quench messages. PICMP minus ICMP minus type 0 refers to all echo reply packets. The number 0 corresponds to the type echo reply. The exclamation point is not a condition by itself, but it applies to all optional expressions listed here. The exclamation reverses the logic of the expression. For example, where -p47 means protocol 47, -p exclamation point 47 means not protocol 47 or all protocols except for protocol 47. -j target. This is not an optional expression, but rather specifies that a packet should be sent to a specific target. For example, -j drop means that the packet should be sent to the drop target and thus discarded. So I'm going to leave this video here for this evening. If you like listening, please consider like, sharing and subscribing. Thank you.